We're continuing with solving equations that involve logarithms. Um, there's an assortment of different tricks here. We saw several in the last video. This one is real clever. Let me show you this one. So I've got e to the 2x minus e to the x equals 56. Well, these can't combine. I mentioned in the last video, if this works like a variable, these are two of the exact same thing, e to the 2x. But e to the 2x and e to the x are not. That is not identical. So this doesn't work. It's like two terms. It's as if they're just like x and y. I cannot combine them. So the trick that we're going to do, let's see if I can use theirs. Okay, so I'm going to get this, and I'm going to swing 56 over to the other side. So here's what I've got. Now, what good is this here? Well, let me show you a trick. I don't know if are they going to sub it? Okay, so here's what I want you to think of it. If this had been x squared minus x minus 56 equals 0, you would know what to do. You could factor this. Find the two numbers that multiply to get negative 56, add to get the negative x. This is going to work exactly the same way. Now, what you can do is think of it like this. Think of it like a substitution. And it's always going to be the lower exponent. Do you see how this is e to the 2x? Couldn't you think of that as e to the x squared? Do you see what I mean? Wouldn't that be you'd multiply the exponents and you'd get to the 2x? This is the same thing as this. Now, you could maybe see just how you're going to follow a pattern we already know, but the way you could think of this is I'm going to substitute. I'm going to say that u is equal to e to the x. Okay, well then I create this. I'm going to say u is e to the x. Well, this is then u, and this is u squared, right? Isn't this u? Now, we could solve this just by factoring. And I solve it, I'm going to get u is 8 and u is negative 7. Okay, but this wasn't about u. It was about e to the x. So I'm going to unsubstitute here and make it e to the x equals 8. I'm going to unsubstitute here and say e to the x is negative 7. Now, we know how to do this. We have isolated the difficult portion of the problem. I can take the natural log of both sides. And if I do that, I'd be left with x equals the natural log of 8. And over here, x is the natural log of negative 7, but I can't, this is not an acceptable answer. Remember, we saw you can't take the log of a negative number, so that must not be a real solution. And here is my answer to the problem. Okay, so you're welcome to pause and try this on your own if you'd like to. I'm going to show you here. I've just swung everything over to the other side. And I'm going to use the substitution. If you don't need to sub it, you don't have to. So again, I'm going to think of it like this. So my substitution is going to be u is e to the x. So I've got u squared minus u minus 2 equals 0. Well, we know how to do this. It'd be u minus 2, u plus 1 equals 0. We solve that, get this. Now, it wasn't really about u. U is really e to the x. So I've got e to the x equals 2, e to the x equals negative 1. Take the natural log of both sides. We're going to get x equals the natural log of 2. And then you see here, this one's not going to be, we're going to have x equals the natural log of negative 1, which is not true. Excuse me. Okay. So this is going to be the same idea. First of all, I have a problem area that this natural log of x. So what I want to do is I want to get that alone. I'm going to do all the normal stuff as if this was 2x plus 3 equals 7. So I'd get rid of the 3, divide by the 2. Okay, so I've done that here. So I did all my early steps. I was wondering what was happening. That should be an equal. Now, we have the ln of x equals 2. Well, there's a couple ways to think of this that you could solve this, but I want to go like this. Log of e to the x is what a natural log is, right? Well, here's what this says. e to the second power equals x. Remember what a log meant? E to some exponent turns into x. Well, what is the exponent? I know it's 2. So basically what I'm saying is we're using the definition of a logarithm to solve this. So e to some exponent turns into x. Well, it's 2. So e to the 2 equals x. I'm going to switch between the different forms. Remember, when we first began learning about logarithms, we saw that it was equivalent to say e to the 2 equals x. So I'm going to use that bit of knowledge and just go ahead and switch. Well, here's why that was helpful. That tells me the value of x. X is e to the second, which is a real number. You could crunch that, but I would be happy with you just leaving it as e to the second. A mathematician would probably appreciate it that way. So we've got another one here. If you want to work this, we're going to subtract 6 from both sides. And I've got the ln of x. I've gotten the difficult portion isolated, and now I have it alone. Now remember what this really means. You don't have to show this, but just want you to remember a natural log is an e-based log. Okay, so let's switch it over to the definition. We saw that you could switch it into the exponential form, and so x would be e to the fourth. Okay, you'll see this here. We're going to isolate this difficult portion here by dividing both sides by 2. Now, I'm going to switch. So I've divided both sides by 2. Now I've got the difficult portion alone. So let's switch to the definition. E to the 7 over 2 must be equal to 6 over x. Now, the only thing that's changed here is I've got one extra step. I'm going to divide both sides by the 6, and there's my answer. Okay, let's do this again here. I've divided both sides by 2 to get the problem area all by itself. Now we know, and I could show it, but this is going to be e to the fifth must be equal to x plus 1. So if I'm solving for x, I'm going to get x is e to the fifth minus 1. I don't think I would ever ask you to do this, but we saw this earlier, I think, in this textbook. So what you could do is think of this as if I graphed a line y equals 3, and where that intersects with the graph of the ln of x is the solution. We saw that idea earlier, and it's clever. I'm assuming you could find some use for that, but solving it wouldn't really be necessary. So this is just the graph of the ln of x. They just graphed it. Now they've also graphed y equals 3. So basically what we're saying is when is y equals 3? It would be the point where they intersect each other. And you could read that off technology. I don't know that would be all that valuable. Yeah, again, the same thing. So what I would do here is that I would graph just 2x here. And I would also graph y as 1,000 on a calculator. See where those points intersect to get an approximation for this. I'm not really sure that would be all that useful. What I would do to solve this would be we have an exponent up there. We want to get it down. So I'd take the natural log of both sides. Would allow me to bring that out front. Now, to solve x by itself, I'd get x is the ln of 1. Oh, I had too many zeros there, sorry. 1,000 divided by the ln of 2. That's how we did it in the last section, and that'd be fine. I would just do this on my calculator, and that'd be the end of it. Okay, so we have another idea here called the one-to-one property of logarithms, but we've already seen this. What we said earlier in the last section, if I had an equation like this where the bases were identical, then the bases have nothing to do with it. Well, it's true here again. If I have two logarithms and there's nothing else, they're both logarithms of the same kind, same type, they're both natural logarithms, then all I have to do is I can ignore the logarithms, and it's just x to the second equals 2x plus 3. Solve that by factoring, and you're using the zero product property. If you don't remember the name of it, that's all. You just factor it, solve each side for 0, and I have my two solutions. Okay, so you do need to check. I didn't think about that. I'm not sure what the reason would be why it could break it. I guess it's possible. So they're double checking their two solutions to make sure it doesn't make a logarithm a negative, but in both cases they're fine. So they're all right. Okay, so I have two logarithms, and that's all there is. They're the same type of logarithm, so I can turn this into x squared equals 1. We could solve this multiple ways. I like to do it like this, even though it's probably faster. So I would just factor it down. So x is going to be 1, and x is going to be negative 1, which you probably saw another way faster than me. But okay, now this is talking about the decay. We're going to have a whole section on this, so I'm not sure why I put this in this section. So this is all. We're going to just solve these different types of equations that we've seen here. I do have a type of problem that I see that I didn't have that I may need to make a supplemental video, but that'll get us started.